In this video, we're going to be using the law of cosines to solve a triangle in which you are given three side lengths. In a previous video, we used the law of cosines for the side angle side condition, where you were given two side lengths and an included angle. And we talked about in that video why the law of cosines is structured the way it is, how we set up each of these equations, and gave you some of the background then on the structure of the equations themselves. In this video, though, we're going to jump straight into the solution of this side case. So if you need a description of how these equations are set up, I suggest you go back to that previous side angle side video where we then describe those processes in more detail. Okay, so in the case of our example here, triangle ABC has side length A, 5, B has a length of 6, and C has a length of 10, and we're asked to then solve the triangle. In other words, find the measures of the three angles, angle A, angle B, and angle C. Now, my advice when you're given three side lengths is to always start with the equation that corresponds to the side of the longest length. So in this case, C has the longest length with a length of 10, which means I'll want to start with this equation, the C squared equation, in order to find the measure of angle C first. We know that in any triangle, the largest angle is always opposite the largest side. So what we're going to be determining here by starting with that largest side, if this triangle has an obtuse angle in it, or if it has a right angle in it, we're going to be finding that angle first. And we'll talk about a little bit later why that's important in terms of the solution process. All right, so first things first, we're going to copy down that equation and then substitute our values into it. Once we have our values substituted, then it's a matter of using those algebraic properties that we know in order to solve this equation for the measure of angle C. In the last video, we talked very detailed about the process of going through these steps in the order of operations, parentheses, then exponents, multiply and divide, and lastly add and subtract, and how we go about using then those steps to find a missing angle measure in this law of cosines. Here we're going to abbreviate that process just slightly. I'm going to go ahead and square this, and we'll just bring that straight down. We'll square these two numbers and add them together. And we're going to go ahead and multiply these three values that form the coefficient on that cosine of angle C. All right, once we've got it to that point, we know that we cannot subtract this 61 minus 60 because the 61 is a constant and the 60 represents the coefficient on this cosine C term. So instead what we'll do is subtract that 61 from both sides. And since that negative 60 is a coefficient, we'll go ahead and divide that 39 by a negative 60 to determine what the cosine of angle C is equal to. And in this case, we end up with negative 0.65 is equal to the cosine of angle C. Now, from previous experience, we know that in order to find that missing angle measure, to get rid of that cosine that's attached to it, we apply an inverse cosine on both sides. So in this case, the inverse cosine and the cosine are going to cancel. And what we'll be left with on this left side, when we apply that inverse cosine, is the measure of that angle C. And in this case, the measure of angle C is 130.54 degrees. And we know that's an approximation, but ultimately there's the measure of our angle. All right, so our next step then is to determine the measures of angles A and B. It does not matter in which order you do these two or find these two angle measures. You can choose which one you want to start with, and the way that you do that is by selecting which of these two equations you want to use. Now, if you go to some websites or some books, they will also tell you that at this point you could then go back to the law of sines to find those missing angle measures, and that's absolutely fine. as long as you have found the measure of the largest angle first. The problem with starting with one of the smaller angles and then jumping into the law of sines is if I had found, let's say I found the measure of angle A here first, which in this case, because I know the measure of angle C is obtuse, when I find the measure of angle A, I know it has to be acute. So let's assume that I had started with the measure of angle A, and I found it to be an acute measure, which we will find in a moment, and then I went into the law of sines. The problem with the law of sines is that it does not find that obtuse angle measure for you. Cosine is very sensitive in that whenever we do this inverse cosine of a negative, it's automatic that that has to be an obtuse angle measure. When you take the inverse sine, though, what we're going to end up with is not an obtuse angle measure. So using that law of sines, after you've found an acute angle measure with the law of cosines, can sometimes be dangerous. So my advice, start with the law of cosines with the largest angle first. If there's an obtuse angle or a right angle, you're going to find it right away. For your second step, you can choose to use either of these two to find either the measure of angle A or the measure of angle B, or you can go back into your law of sines and find the angle measures in that way. It is entirely up to you as long as you found the largest angle first. I'm going to go ahead and use the a squared equals etc. law of cosines equation just to give us some further practice with that, but we could go back to that law of sines as I said. All right, so I'm going to start with my equation and then substitute into it what I know. And now the process is going to be very similar to what we did up above. We're going to square this first number and just bring it down, square these two values and add them together, and we'll go ahead and multiply those three values that form that coefficient on the cosine of angle A. Now, some would say that this is kind of a daunting process, that it's very long, but ultimately, once you get this kind of habit down as to how you want to go ahead and simplify this expression, then it's some simple steps of subtraction, division, and then that inverse cosine to find your angle measure. All right, so in this case, we're going to subtract that 136 on both sides, divide by that negative 120 on both sides. And then lastly, apply our inverse cosine. So you find that once you do this enough, the process really isn't all that long. It seems like it is initially, but it's not too bad. Okay, so the inverse cosine of that decimal in this case gives us an angle measure of 22.33 degrees for the measure of angle A. Now, for the finding of the third angle measure, you've got two options. We could go back to the other version of the law of cosines. In this case, it would be the one that starts with a b squared. And we could then find it that way. Or you could simply use the triangle sum theorem. We know that the measure of angle B would then have to be 180 minus this 130.54 for angle C, and subtracting the 22.33 for the measure of angle A. And this just generally is kind of the shorter of the two processes in terms of whether you want to just subtract or if you want to go back to using your law of cosines. And we end up with an angle measure of 27.13 degrees. And that's it. That's the entire process. So in terms of the process here, remember, always start with the side that's largest, which is going to guarantee that if there is an obtuse or right angle that you'll find it right away. And then either use the law of cosines again in a different form, or you can use the law of sines for that second step to then find the measure of either of the other two angles. And that's it for the law of cosines.